Okay. Thank you guys for coming in. Now we can start with the lesson. I need you guys to tell me if you can hear me and if you can see the screen. Okay, thank you very much. Thank you very much for confirming. Remember, this lesson will focus on, we said paper one, ne? We'll focus on paper one now. I think everyone understand the structure of paper one. So, we're just gonna first start with question one, but we're not going to do everything on question one. Most of the time, we'll focus on those most difficult questions on equations and inequalities. So we're going to start with equations and inequalities. Right. So now, what I know is that most of the learners, you guys struggle with 1.3 questions that has to do with nature of the root, equations and inequalities. Right, so we're going to start with those type of questions. I know that most of you are currently, you guys get problems when it comes to nature of the roots, which is 1.3 of your question paper, which is what we're going to start with working on. Okay, I hope everyone understands that part. So now remember, if I need to determine the nature of the roots, we'll start with the basics. Let's say I want to determine nature of the roots. Right. So if I want to determine the nature of the roots, there are some of the things that we need to work on. If I say the nature of the root, remember we use the discriminant, it's equals to b squared minus 4ac. So this is the formula that we use for the nature of the root, and make sure that, number one, before you use this equation, you need to write the equation in standard form. I hope everyone understands that. We need to write the equation in standard form. When we say standard form, we are referring to the form of ax squared plus 3x plus c. So if you understand what I'm going to explain on this one, then this tells me that you won't get 1.3 question wrong. So because most of the time this question is on your paper 1 1.3. Right. So let's say I'm given x squared and this is plus 3x and this is equated to negative 2. Can you see that what we need to do first is to rearrange the equation? I hope everyone is with me on that. We need to put it in that form, the standard form. So this will give me x squared plus 3x. The 2 will come this side to be positive, and now I can equate this to 0. So it is in the correct form. You just have to tell us what is the value of a equals to, what is the value of b equals to, and what is the value of c equals to, so that when you substitute, you need to make sure that everything is correct. Now the value of a here is 1, and I have the value of a which is 3, the value of b is 3, and the value of c is positive 2. So if I'm looking for the discriminant, the discriminant is equals to b squared minus 4ac. Now, when we substitute, the value of b is 3, so this will be 3 squared minus 4 into the value of a, which is 1, and then c, which is 2. So you need to punch that on the calculator. Ne? You need to punch that on the calculator, and you'll find that your discriminant, this is 3 squared minus 8. So it's 9 minus 8, which gives us 1. So the discriminant is 1. Now, what about the nature of the root? What are we going to comment about the nature of the root? What are we going to say about the nature of the root? So now listen. Remember, we said that the nature of the root, we use the discriminant. Ne? We use the discriminant, and now when we use the discriminant, we need to understand the map. The map that is used to do what? The map that is used to find the discriminant. I hope you guys understand that part. Ne? Listen, the map that I'm referring to, it will start with, like, saying, I have, if you understand this map, you are good to go. So the map starts like this. If your discriminant is less than 0, it's going to be non-real. Okay, non-real. If it is negative, if this one was negative, then we were going to say the discriminant is what? We were going to say now, Evelyn, can you see the screen? Guys, can you all see the screen now? Can you please comment fast, because I see other learners are struggling to see the screen. Are you all happy? Can you all see the screen? Evelyn, you good? I'm waiting for your comments. Can you see the screen, guys? Yes, we can. Okay, great. So if the discriminant is less than 0, it's going to be non-real. Then now I need you to say, if the discriminant is greater or equals to 0, we're going to have two types. Né? We're going to have two types. So this one, okay, if the discriminant is greater or equal to 0, this is going to be real. We're going to have real roots. If you don't understand the map now, please just stay with us. As we move, you're going to understand how this map works. So if your discriminant is greater than 0, is greater or equal to 0, we say the roots are real roots. So if it's less than 0, this is where we stop. The map will end here. This is the end. Now, if the discriminant is greater than 0, if it's greater or equal to 0, it's either your discriminant is equal to 0, or you're going to have your discriminant to be greater than 0. If it's equal to 0, we're going to have what? Is it equal or unequal? Are we going to have equal roots or unequal? We're going to have equal roots. Are you all with me on that? Kanyisa, I can see your comment. Ne? I see your comment. So, if it's equal to 0, it's going to have equal roots. Someone can say 2 equal roots. And if it's greater than 0, it's going to have 2 unequal roots. Right. So if the discriminant is greater than 0, this is where we stop. This is the end. But now, if it's greater than 0, we're going to continue moving down. We need to understand that is the discriminant equals to not a perfect square, or is the discriminant a perfect square? Is the discriminant is equals to a perfect square? So guys, please forgive me. I'm just gonna remove this now. We'll write this somewhere. We are coming back to this problem because there's nothing we can do if you guys don't understand what is going on here now. Today we're going to push a very long session. I'm not sure who's going to be the last man standing. The issue of our issue now is that we start our lessons early, I mean late, né? That's the issue now, but we're going to work on that, né? So if the discriminant is a perfect square, this will be rational, and if the discriminant is not a perfect square, this will be irrational, right? The nature of the root will be irrational. Irrational. Rational roots, irrational roots. So guys, I'm going to explain this, don't worry, when we keep on making, when we keep on doing examples. Now for now, I just wanted to put the map. Let me show you how this map works. If you understand the map, you're going to get most of these questions right now. If you understand the map, you're going to get no. Greater than 0. If it's equal to 0, someone is asking real equal. Oh, you even removed the comment. Okay, so now look at this now. Now we can find the discriminant. We said that the value of A is 1, the value of B is 3, and the value of C is 2. Therefore, the discriminant is equals to B squared minus 4AC. 4AC. So now when I do the substitution, I have my B as 3, which is squared minus 4 into A, that's 1, and C, which is 2. And we said that the discriminant is equals to 1. Look at this 1. We need to comment on the 1. We can see that the 1, we know that 1 is greater than 0, right? So if it's greater than 0, we'll move in that direction. So now the first answer that we get is that it's real roots. So we need to write down that it's real roots. So the nature of the root, we're going to list them down. So the first one, we need to write it down here. The first one, number 1, it's real roots. The roots will be real roots. So now since it's real roots, remember we said it's greater than 0, we move in that direction. The first thing that we get on our map is real roots. So we still have to go down. Is the discriminant 0? No. Then we're going to move in this direction. We're going to move in this direction. Then this is greater than 0. So we know that it's greater than 0. We're going to write the second one, which is unequal. Then I'm going to write it down. Unequal. Right. Then I need to continue going down with my map. I check. It's 1 a perfect square or not a perfect square? 1 is a perfect square. The square root of 1 is just 1. Then I'll move that direction. So 1 is a perfect square. So if it's a perfect square, therefore the last one is rational. They need you to list all of this nature of the roots. Real, unequal, and rational. And I know that most of the time when you see them like this in an exam, you become more confused because you don't understand where is that answer coming from. Are you guys happy with this? Do you guys understand what is going on here? I need you to be honest. If this is the first time you see how to answer the nature of the roots, I need you to be honest, né? Are you all happy with this? Because we are about to do a second example, né? Surprise, please be honest. If this is the first time you see this, I need you to be honest, because you guys need to understand why it is important to join those private programs, né? Because now, when you join the private programs, the one that we are currently working on, this shows that I'll put more attention to those learners, né? And you'll be missing out. So make sure that you join those programs, né? So that we can be able to train you how to be the best. This is my first time, but I'm getting it. Yes. So this is how it works. You just have to know this thing. If you can cram the map and understand the map, you'll be good. First thing first, we start is it's 1 greater than 0, yes, then we know we'll move that direction. We go down, therefore the first thing that we get is real root, you write it down. So you check, it's 1 equals to 0, no, we move that side because it's greater than 0, then it's going to be unequal roots. So now you need to check, it's 1 a perfect number, yes or no, then if it's not a perfect number, then we move in that direction. Even on exam, we have to comment whether it's rational and all. Yes, you need to comment. Well explained, that the map makes sense. Yes, the map makes sense. Ne? So this is very important that you join the program so that you can learn more. Let's do the second example. Ne? Let's do the second example. Let's see what we have here. So now, let's say I have this. Ne? Number 2. Let's work on this. Let's say I need to find the nature of the roots for this equation. X squared minus 6x plus 9 it's equals to 0. So this is my equation. I need to do what? I need to do the nature of the roots. Remember the first thing, find the discriminant. You need to know what is your value of A. It's 1. The value of B is the coefficient of x, which is minus 6, and the value of C is just 9. Then we're going to substitute all the values. Where there's B, we can put minus 6, this is squared, minus 4 into A, it's 1, and C is 9. Then you just have to punch that on the calculator. 6 squared, 36. 4 times 9, 36. So this will be 36 minus 36. Minus 36, it's equals to the discriminant is 0. So if the discriminant is 0, we need to find the nature of the roots. Remember, the discriminant is 0. So the discriminant is not less than 0. I move in that direction. Okay. Then the first thing that I get is real roots. I need to write it down. So 1 is going to be real roots. Let's go find the second nature of the roots. So since it's greater than 0, the discriminant is 0. It's equal to 0. I'm going to move in that direction. So when I move in that direction, I have equal root. Then this is the end. This is where it ends. So this will be equal. So the nature of the roots is real roots and it's equal. Then you are done. We did this is how we conclude. Ne? This is how we conclude. So the more we do, the more questions with, the more examples we do, the more we can add more complex problems. Ne? Let's try this one. Let's say I have 6x squared minus 6y minus 1 is equal to 0. Let's work on this. Not minus y, but minus 6x. This will be minus 6x. We minus 1, this is equal to 0. We need to find the nature of the roots of that. Ne? Let's work on this. So I'm going to say the discriminant is b squared minus 4ac. Now I need to list my value of a is 6, my value of b is minus 6, and c minus 1. My discriminant will be b, which is minus 6 squared minus 4 into 6 into minus 1. Therefore, we punch that on the calculator. We get that 6 squared is 36. 4 times 6 is also 36. Then this will give us 72 when we add the 2. So this is 36 plus 36. And the discriminant is equal to 72. So the discriminant is greater than 0. This is how I'm going to move. I got my discriminant, which is greater than 0. So now the discriminant is greater than 0. We go in that direction. We go down, so it's going to be real roots. I'm going to write it down and say, number 1, real roots. Then let's go and check there. Since it's real roots, we have 72. It's not 0. we move in that direction. Where we stop, unequal, then I'm going to write number 2, unequal. Then number 3, I'm going to say, now I need to check, is 72 a perfect square? When you punch the square root of 72, you won't get a whole number, né? So we move that side. It's not a perfect square, it's going to be rational. Then I'm going to write the last one is irrational. I'm sorry, it's irrational. That's how you find the nature of the roots. But let's say that we get a discriminant that is negative. If the discriminant is negative, it's just going to be non-real. Né? If you find that your discriminant is negative, then it will be just non-real. Okay, I hope everyone is happy with that. Né? So let's go to another part of the what we call the nature of the roots. Né? Let's say okay. I hope you guys are with me, but before I continue, let me check if we have any questions from other learners. Do you guys have any questions? How? What's wrong with 72? What happened? Did I do something wrong here? Let me have my calculator. I see everyone is not happy with the 72 answer. Let's put this on the calculator. Minus 6 squared minus 4 into 6, close the bracket, into minus 1. We get 60. Oh, okay. Oh, okay. I'm sorry, guys. This is wrong. This should be 60. The discriminant is 60, not 72. Né? The discriminant is 60. So now this tells me that this might also be wrong, but we understand even if the discriminant is 60, we still get real, unequal, and rational. So the discriminant is the one that was wrong. Thank you, guys. The 6 is negative. Come on, guys. What's wrong? The 6 is negative? No. Yeah, I think it's 60. We did it like this. It's 60. Thank you very much, né? Thank you very much, guys, for correcting me. Thank you very much. We'll move to the next phase of the nature of the roots. Okay, I see, guys. I see your comment. The Amingo, I'm so late. No, it's fine. You can continue with us, then you'll catch up on the recording, né? Listen, guys, né? If you leave the session with the aim that you will watch the recording, tomorrow we're uploading another recording. The day after tomorrow we go live again. You see, now you won't be able to catch up. So it's best that you sit in the lesson, you work with me. So imagine if you say you'll watch the recording, then you don't even understand the recording. How are you going to ask questions? Because the live gives you the opportunity to ask questions. Okay, let's work on this level. We're going to work on type 3 and 4 questions now. Né? The one that you should expect in an exam. So let's say this week, let's call this one the exam type questions. We're going to call them the exam type questions. So on the exam type questions, you'll be given something like this. Let's say I have x squared plus bx minus 2 plus k into x squared plus 3x plus 2, and they tell you that this is equal to 0, and there's a condition there that says k must not be equals to minus 1. Okay, then the first question says that show that the discriminant is given by the discriminant is equals to k squared plus 6bk plus b squared plus 8. So they just want you to find the discriminant, but your answer should be k squared plus 6bk plus b squared plus 8. So I'm sorry, what I'm going to do to answer this question, first thing first, I need to make sure that whatever that I'm currently working on, we put it in what is this? Okay, maybe we should just write the questions first. That was the first question. The second question, I'm not sure if we should let's answer this one before we go to the second question. Let's answer this one first. So I know that they want us to calculate the discriminant. So but now we need to find, remember, the discriminant, it's equals to b squared minus 4ac. But I don't know what is the value of a, what is the value of b, what is c, because this thing is not yet in standard form. So I'll try by all means to rewrite my equation down so I can put this equation in the form of ax squared plus bx plus c. So this will be x squared plus bx. I'm going to minus 2 plus k inside the bracket. I still have x squared plus 3x plus 2. This is 0. So let's multiply out the bracket and combine the like terms. Let's see if we multiply out the bracket, do we have the like terms? This will be plus. This will give us, we need to multiply out the bracket with what? We need to, okay, let's do this. We need to multiply out the bracket with that k. So this will be plus k squared. It's x squared k. And then I have plus, which one should we write first? K or x? So k will be the coefficient of x squared. So I think we need to write this as k x squared. So it makes sense if we say this is k x squared. And then what's next? We need to multiply the 3x with the k, which will give us 3k x plus 2k. This is equal to 0. So I'm trying to check if we have any like terms here. Do we have any like terms? Let's combine the like terms. You know, when I say combine, I need you to group them. When I say group them, I need you to take the x squared, write it next to kx squared. Let's start with that one. Guys, I'm trying here. I want to move slow so that if someone will be watching the recording later on, they'll be able to understand. So this is x squared. I'm going to bring this k x squared next to that one because I need to take out that x squared as a common factor. This will make sense now. Don't worry. So I'm going to highlight the other like terms that I can combine. together. So this one, the bx, I look at the coefficient x. I'm going to look at another one that has the coefficient of x, which is this one. So I need to combine the bx with the 3kx. Let us do that now. So when I combine the two, this will be plus. I have that bx. I need to add the 3kx. Now I can just take my 2k and subtract the 2, equate this to 0. So now can you see that I need to take out the common factor as x squared. But listen, when you take out the common factor as x squared, this is how you're going to write this thing. This is like saying 1 plus k, then we have the x squared out. So I know that most of the time when we take out the common factor, we put it this side. I'm going to explain why I need you to put it on the other side, because remember, we are trying to write this in the form of ax squared plus bx plus c. So now the value of a should be this one. It should be in front of x squared, just to show that 1 plus k is the coefficient of a, is the coefficient of x squared. So the value of a is 1 plus k. We do the same. We still have the x here as the common factor. I'll have this as b inside the bracket. I'm going to say this is b plus 3k, the x outside. So the coefficient of b here is what? It's b plus 3k. Then we need to find the value of c. The value of c, it's everything that doesn't have what? It's everything that doesn't have the coefficient of x, the variable x. I'm sorry now. So look at this. This is my a. Everything here is b, and this will be my c. If you understand how we did this, then now you are ready to substitute everything in this quadratic, in this discriminant formula, and you should get your answer like that when you simplify. Let's try and see if we're going to get the same answer now. So we're saying that the discriminant is equals to b squared minus 4ac, and then the discriminant is equals to, where there's b, we need to put b plus 3k. Everything. Square that guy, minus 4 into the value of a. It's 1 plus k, but I'm going to write it as k plus 1. And this should be what? Multiplied by c, which is just 2k minus 2. So this is your discriminant. You just have to multiply out the bracket, add the like terms, and see what you get. So first thing first, let's expand. I'm just gonna expand the, let's expand the, what is this? The b plus 3k, and see what we get. So we know that b plus 3k squared can be written as b plus 3k into b plus 3k. So look at this. B times b is b squared using the FOIL method. B times 3k, this will give us, what is this? This will give us plus 3bk plus 3bk plus 9k squared. That's the FOIL method. Ne? We are using the FOIL method. We multiply out the bracket, and this is what we get. So when we add the like terms, this guy here will be equals to b squared plus these two are the like terms. So this will give me 6b k, we add 9k squared. This is what I need to substitute here. Can you see? Everything now is coming. We're going to get that answer that they are looking for. So this we know is b squared plus 6bk, then we add 9k squared. So now we need to multiply out the bracket, and everything must be multiplied by that 4, that minus 4. So we need to multiply out the bracket. So I'm just going to leave the minus 4 outside and multiply out the brackets. So this will give me what? 2k squared, then minus 2k plus 2k. I'm just gonna jump. Look at this. I have 2k squared minus 2k plus k, which will give us 0. Then we'll have minus 2. So guys, I just want to jump a step here. Please just sit down, multiply out the brackets, and then you'll see that this will give us 2k squared minus 2. Because look at this. This times this is negative 2k, and then this times this is positive 2k. So they just cancel, which gives us 0. So now the next thing is for you to multiply out the bracket with the negative 4. So I'm going to have this as b squared plus 6bk. We add 9k squared minus 8k squared, because we are multiplying out the bracket with what? With the minus 4. Then this will give us positive 8. So let's see. They said they want us to show that this is k squared plus 6bk plus b squared plus a. I think we have the answer already now. But now we have the like terms that we need to combine. Look at this. These two guys are the like terms. So when we say 9k squared minus 8k squared, this will give us b squared plus 6bk plus, and 9 minus 8 is just 1. So we'll be left with k squared plus 8. So if I compare these two things, I need to write k squared first. I need to first write, I just have to rearrange because we are adding, the order doesn't matter. We can, you see now, okay, I just got distracted. Ne? Yeah, okay. So now we can just arrange this thing, because remember we said the order doesn't matter. So this will just be k squared, then we add the 6bk, then we can add that b squared that they are looking for plus 8. We just have to rearrange this so that we can get whatever that they are looking for. Guys, I know that this is long, but trust me, I'm going to explain why I'm teaching you guys this question. I'm going to explain why you need to understand this question. This is the exam type question, but not most of the time you'll get this one. You can only get this in your March control test, but in your June and November, I'm going to show how they're going to ask this. How they're going to ask this. One thing that I need you to learn here, the most important thing is for you to be able to multiply out the bracket with k and also combine the like terms. I also need you to know combining the like terms like this so that you can take out the common factor. I need you to learn how to find the value of a, the value of b when the question is this mixed up. So that's why we are doing this example. We are doing this example to train you how to arrange the equation to be in the form of quadratic equation. So when you understand that one, I need you to be able to do what? To know that everything that is x squared, the coefficient of x squared is the value of a. I hope everything makes sense now. And everything that doesn't have x, it will be the constant value. I hope this makes sense. Now let's work on the second question. So the first question, they wanted us to show that the discriminant is given by that, and we've managed to do the proof. Let's move to the second question. The second question says that if b, number b, if the value of b, if b is equals to, but let me pause here and see if I have any questions on the other side. Let me see. I'm also late, yo. Everything makes sense. Soli, thank you. Wow, you are extremely good. Can we talk in private? Yeah, common factor of 2. Why are you guys so surprised? Is it the first time you see this, guys? I told you. You see, if you are not joining the program, I'm telling you, you're going to miss out. That's why I'm saying we are going to get that goal mark of 70%. Ne? Someone is saying common factor of 2. Hibo. Okay. Sorry, you always tell me that I'm good. Ne? I think, no. I think everyone is happy. I think everyone is happy. Guys, you see, this is how you do the questions. You just have to I just hate, you know why? Most of the time, guys, I don't teach on TikTok. I started teaching a few weeks back because each and every time when I go on TikTok, I find most tutors doing algebra. Each and every time when I log in, they're doing algebra. Each and every time, and they're doing inequalities, like those easy questions. But there's this other one is doing organic chemistry. That's good. We should focus on more complex. I can't teach you level 1 and level 2 questions. These are the type of things that we need to focus on, because I know that already you know how to. Why should I go live and teach you how to solve for X if this is given like this? And this is 2 marks. You see, I need us to work on more type 3 and 4 questions. Ne? Right. So someone said we should talk in private. Who's this? Okay. UJ, I'm not sure how I can we talk in private. Yes, you can just reach out on my number. You have my number. You can just reach out. Now I'm not sure if I'm allowed to say my number on what is this on YouTube. But if you are not able to find me, just follow the Facebook link here on the YouTube channel. Maybe just reach out on that Facebook page. Then I'll definitely respond to you. Ne? I'll definitely respond to you. Faith, welcome. So now, Evelyn, I'm coming to you now. I'm coming to you. Don't worry. I see your comment, and I can see that you are up to something. We are coming to you. We're going to work on more questions on that. Then we'll come back to your comment. Don't worry. So they say that if the value of B is 0, if we have the value of B, so now they say if the value of B is 0, they want you to discuss. They want you to discuss the nature of the roots. They want you to discuss the nature of the roots. Right. So, if they want you to discuss the nature of the roots of this equation, this tells you that we know that I'm not going to waste too much time on this one, because I know that I'm given K as 0. I'm given B as 0. So what will be my nature of the roots? What will be the discriminant? First thing first, I need to put 0 where there's B. So this will be K squared plus 6BK plus B squared plus 8. So where there's B, we need to substitute 0. This K squared plus this will just give us 0. This will give us 0 plus 8. So what is the nature of the roots now? If B is 0, the nature of the root is just K squared plus 8. So now we need to decide. About the nature of the roots. Né? So how do you do this? Listen. Né? The discriminant is K squared plus 8. So this is positive for all values of K and greater than 0 for all values of K. I'm not sure if you guys understand, but I'll give you an example now. What I'm saying is that this is positive. Né? In order for the discriminant, your discriminant will be positive. So the discriminant is positive. Né? But it's positive for all values of what? For all values of K. Listen, whatever number that we substitute on K, it will stay positive. If I put -1, remember, it is squared. Anything squared, it will always be positive. Minus 100 squared, the answer will always be positive. I know that you guys understand that part. Né? So the discriminant is positive for all values of k. So now, for all values of k greater than 0, and the discriminant, it's what? The discriminant, it will be greater than 0 for all values of k. So we know that the discriminant will always be positive and it will always be greater than 0. So our discriminant, there's no way we're going to get the discriminant at 0. Why? Because k, even if we put 0, we still have 8. So this tells you that the discriminant won't be equal to 0. That's what we know now. This tells that, let's say, if I put k to be equals to 0. If k is equal to 0, what is the discriminant? The discriminant will be 8. So if we say k is equals to, what is k? If k is equals to minus 1, what is the discriminant equals to? That will be minus 1 squared, it's 1, plus 8, this will give us 9. So the discriminant will be 9. Even if k is equals to 1, you see what we are getting. So the roots will be what? The roots will be real and unequal. Look at this. Look at the map. We know that the discriminant will always be greater than 0. We're going to start from, let's use a different mark. We're going to start from this point, go that side, and then this one. So we start at real roots, and then we go down. We know that the discriminant will never be equal to 0. I'll go that side. And then now the discriminant is greater than 0 for all values of k. So it will be unequal and real roots. We cannot specify if it's going to be rational or irrational. Ne? We cannot. So this is where we're going to stop. So the nature of the roots for this, if the value of k is, if b is 0, we're going to say therefore it's going to be real and what? It's going to be real and unequal. So the reason is that we cannot say if the roots are rational or irrational, because since this depends on the exact value of k. I hope everyone is happy with that. Now let me stop. Maybe we have questions this time. Let's see if we have any questions. Uh, 6bk, you substitute b0, then where's k? Mapinini, Kuzo, let me tell you something, ne? Let me tell you something, Kuzo. Let me tell you something, Kuzo. Listen, Kuzo. You are saying that, Kuzo is saying, it's asking, if I have 6bk and we substitute 0, tell me, what is any number multiplied by 0 equals to? What is any number multiplied by 0 equals to? So now, I have a question here on the comments. Someone is asking that what happened to, I have 6bk. So where does b I put 0? This is 0 times k. What is the answer, guys? What is the answer? It's just 0. Any number, even if I can say t multiplied by 0 is just 0. F multiplied by 0, if I say f times 0, the answer is just 0. 0 multiplied by anything is 0. So this is what happened to k. K, we multiplied, because this is 6 times 0 times k is just 0. Those who are asking, because on Tatila, I see on Tatila saying, I also wonder what happened to k. Yeah, guys, it's just 0, ne? Oh, I see Evelyn already gave you an answer, guys. Everything multiplied by 0 is 0. I see Evelyn already gave you the answer. Thank you very much, ne? Okay, okay, that's nice, guys. That's nice. Let's keep those questions coming, because remember, we are here to work. We are here to work. So this is some of the exam type question you should expect in an exam, So now I'm going to prepare you guys on the what is this? The now and now remember, I'm saying this again. The reason we did this example, it's for me to train you how to find A, B, and C. So now we're going to work on those type of questions they like in an exam. Look at this now. If we focus on the type of questions they like to ask in an exam, they will ask it like this now. They'll say that show that if I have k squared x squared plus 2 and this is equal to kx minus x squared. So when it's like this, they say show that this has what? Has none real roots for all real values of k. That is the question. They say you need to show that this equation has what? This equation has non-real roots for all real values. Remember, we already talked about this. When it's like this, we need to do what? We need to make sure that we put it in standard form. So trust me, this one will definitely get it in an exam, especially those who are writing match control tests. You should expect something like this. First thing first, let's rewrite the equation down and arrange the equation. So I have this equation, the one that is given, and I'll try to arrange the equation. I need to put the k squared x squared with what? Plus x squared. So the x squared will come this side to be positive. Then I need to minus kx, which will come to the other side to be negative. Then we still have plus 2. This is 0. So now everyone can see that we have the common factor here that we need to take it out, and we'll be left with k squared plus 1. And the squared, we should write it this side, minus kx plus 2. So now we know that the value of a is the coefficient of x squared. Whatever that we have in front of x squared, we need to take everything then. We need to take everything, a, this, b, and c. So now look at this. I have the value of a, I have the value of b, I have the value of c. I can just substitute this in my discriminant formula. So my discriminant is equals to b squared minus 4ac, and the discriminant is equals to b squared. We know that the value of b we said is minus k. This should be squared minus 4 into the value of a, which is k squared plus 1, and the value of c is just 2. So what's next? We need to work out this. This will be k squared. Remember, anything negative squared is just positive that. So it will be positive k squared. Then we need to multiply out the brackets here. So this times that is 2k squared. So this will be minus 4. That we need to multiply with whatever that we get when we multiply out to the bracket. So this is just 2k squared plus 2. Now we need to multiply out the bracket with that negative 4. So this is k squared minus 8, k squared minus 8. I hope I'm not moving fast. But look at these two guys. These two guys are the like terms. Discriminant will be minus 7k squared minus 8. So now, can we take out the discriminant as a negative, and can we take a negative factor? I'm sorry. Can we take the negative out as a common factor? This will be negative inside the bracket. I'll have 7k squared plus 8. I'm going to explain why I'm taking out the negative. So the reason I'm taking out the negative, I know that if I put it like this, it's for me, it's going to be easy to prove that whatever that we substitute here inside the bracket will be positive. Whatever that we put, whatever value of k, any real value of k, whatever that we put inside these brackets here, the answer will always be positive. But look at that. The answer is always positive, but you are multiplying the answer by negative. Then this gives me the power to say that the discriminant will always be less than 0. So the discriminant is less than 0. So we have proved that this equation has non-real roots for all values of k. Simple. Then we are done. Therefore, the roots are non-real. Are you guys allying? Even when we start our lessons late, at the end of the day, we deliver. So please, don't forget, whatever that we have inside the bracket will be positive. But remember, it's multiplied by negative, so the answer will be less than 0 always. Okay. Let's see. Okay, thanks. I see there's no question. I'm just going to move to the next problem. Okay, let's work on the last one. Then we'll move to other type of exam questions. Let's look at this. Let's work on this problem here. Let's say I have the equation let's say I have the equation x squared plus 12x, and this is equals to 3k x squared plus 2. Let's say they tell you that this has real roots. Okay, question number 1. Find the greatest value of k. Find the greatest value of k such that k is an element of integer. Right. We just gonna apply everything. I'm going to show you guys step by step now. Find the greatest value. We need to find the greatest value such that remember they said this has real roots. We are coming to that part. First thing first, let's first arrange the equation. Very important is to first start by arranging the equation. Then now I'm going to bring the minus. Okay, let's group this thing. Now let's put them in order, in the correct order. Remember the one that has x squared, we need to write it next to the one that has x squared. So this will be 3k x squared, but it comes this side to be negative. So we need to say this will be negative 3k x squared. Okay, I have that. Then I still have plus the 12x. I still have to subtract the 2. This is equal to 0. Always remember, taking out the common factor now, I'll have this as okay, I'll have this as 1 minus 3k x squared outside plus 12x minus 2. So now I know what is the value of A, I know what is the value of B, and I know what is the value of C. So this is my A, this is my B, this is my C. So what is my discriminant equals to? The discriminant, remember, now look at this. They say that this equation has real roots. We know that if it is real roots, what is this saying about the discriminant is greater or equal to 0? Let's go back up so that you can confirm that when it's greater than 0, this is greater than 0, the roots are real, the roots are real roots, the nature of the roots. So the discriminant should be greater than 0. What we are trying to say is that when we solve this thing, we should say the discriminant must be greater or equal to 0. Then the discriminant is b squared minus 4ac, and this guy must be greater or equal to 0. We just have to substitute. My b is 12, and this will be squared minus wait, why is the 12? Okay, minus a, what is this? Minus 4, the value of a, it's 1 minus 3k times the value of c, which is negative 2. Remember, this is greater or what? This is greater or equal to 0. Okay, look at this. What is 12 squared? 114. 144, I'm sorry, 144 minus, I need to multiply out of the brackets here. Né? I don't have to make mistakes. I need to multiply out the brackets. So I'm just gonna, this is what I do. The first thing that I need to focus on is to multiply these two brackets by negative 2, so that the answer that I get, I will still have to multiply by minus 4. So I think that is the best way to do this. So I'll have minus 4 outside the big brackets. This will give me 2, which is negative 2, and then this will give me positive 6k. I think everyone realized that when I teach, I don't say 1 times minus 2 what, I just multiply the bracket, because I expect that everyone so far understand how we multiply the brackets. Right? So we multiply everything inside the bracket by minus 2. And also please pay attention to your sign changes, because look at this. Minus 3k multiplied by minus 2, that is positive 6k. So now we still have to multiply the bracket by what? By that minus 4, which will give us positive 8. So this will be positive 8. And then from the positive 8, we're going to say this is positive 8 minus what? Minus, what is 4 times 6? This gives us 4 times 6, 6, 12, 18, 24. So this will be negative 24k. And everything must be greater or equal to 0. Okay, so guys, no time to play. I'm sorry. 1448 plus 8, that is 152. And then minus 24k greater or equal to 0. Look at this. I'm just going to move this here, and I'll say that 152 minus 24k greater or equal to 0. I'll be left with 24k greater or equals to negative 52, 152. Now I need to divide everything by negative 24. Divide everything by negative 24. Remember, we are dividing by a negative. The sign will change from greater than to less than. So this will be less than or equals to. Then you punch that on the calculator. So k must be 152 divided by 24. We get this as 19 over 3. So k must be less than or equals to 19 over 3. So what they are asking is that find the greatest value of k such that k is an element of what? K is an element of integer. I'm going to explain the such that. Well, now what you need to do now, when you answer a math question, a math question, you know what you need to do. Read the first question first, which is say, find the greatest value of k. We know that greatest, we just have to follow about, has real roots. So now we worked on that. So we need the greatest. So look at this. What is 19 over 3 on your calculator? When you punch XD, you find that 19 over 3 is just 6.33. And they said they want what? Look at this. K must be less than or equals to 19 over 3, né? Which is what? K must be less than or equals to 6.33. If I put that on the number line, I'll say this is my 6.33, and K will take all the values going that side. But look at this. They said K must be an element of what? An element of integer. So this is telling you that we need a whole number. So we're just going to take the whole number that we get, the first whole number that we get when we go that side. We know that somewhere here there's 6. This tells you that the answer is that since K needs to be an integer, the greatest value of K is 6. Habash. And that's it. Simple. Nice. Oh, I'm so happy. Yeah, this is good, ne? And that's it, ne? So we're just gonna move to other type questions. I just want to see if we have any questions first, ne? Let's see if we have any questions. Someone, oh yes, I see why we have 24 answers, 633. Thank you, Evelyn. Now we can move, ne? I just want to see who will be the last man standing, because I need you guys. Let's work, ne? Okay. Okay, so now this is the question that might give you problems in question 1. Now we can move to question 2 and check the type of questions that might be challenging for everyone. Remember, we're not gonna work on the ones that you guys already know, but we're just gonna check if we can find something different. Because remember, this lesson we need to I'm sorry, for this lesson we are focusing on paper 1 questions, only the questions that I believe that this one is going to give you problems. So I know that the type of those questions, they have to do with simultaneous equations. Simultaneous questions where you are just given, I'm just going to give you something like this. Those type of questions, I'm just trying to train your mind. Let's say that I'm going to write the statement so that you can see. In sequence and series, this is question 2. So this is question 2 and 3 of your question paper. So this is exam type question. Right, on this one, most of the time, let's say I say the first term, let's say that the first term of a quadratic, sequence, the first term of quadratic sequence is 4, and then the third term is 34, and we are given the common difference. Okay, the common difference, the common second difference. So it's going to be because this is quadratic now, the common second difference, let's say that the common second difference is given as 10. Then they want you to determine the first 3 terms of the sequence. What are you going to do? You find this in an exam, you are sitting in an exam and you see this question. What is the first thing that you're going to do? So now the first thing that we're going to do is to try to analyze what we are given. They said the first term of a quadratic sequence is 4. We know that the first term is the value of a, but don't worry, I'm not going to focus on the value of a. I'll just show you a different approach to work this now. Right, so we are given term number 3, the third term, T3. So they want us to look at this. I know what is T1, I don't know what is T2, but now I know what is T3. So I think these people are playing with us. Let's change this and say maybe we are looking for 4 terms, because already we have 2 terms. Or let's just say we are looking for 6 terms. Now, let's say instead of 3, let's look for 6 terms. So I know T1 is given, which is the first term. It will be 4. So I'm just going to write the first term as 4. Okay? Then T2, I don't know what is that. I'm just going to leave this to be X. And then the third term is 34. They are playing with you. Look at this. They were supposed to say the first 3 terms of the sequence is 4, X, and 34. You see now? They just want you to know what you have here. So I know that when I have something like this, I can let T2 to be X. So what is the difference? Because I'm looking for the difference, which is T2 minus T1. I need the difference like this. Now, the first difference. I need to find the first difference. Then I will also have to find the second difference. So this will be my T2. I need to minus my T1. This will be my T3. I need to minus my T2. So I'm just going to write down here and say T2 minus T1. This is equals to T2, it's X. I minus T1, which is 4. Then I know that if I find my T3 minus T2, this will be 34. I'm going to minus X. Let's see how this information can help us. Now, the second difference will be whatever that we get here, which is what? T3 minus T2. It should be 34 minus X, and this one should be X minus 4. So now to find the common difference, we need to minus these two guys. So what I'm trying to say is that we need to take T3 minus T2. That will be inside the bracket. We need to minus T2 minus T1. And whatever that we get, we need to get an answer of 10, because the answer of this, when we find the difference of these two guys, we need to get the second difference of 10. So I'm just going to substitute what I have. I know that this is just 34 minus x minus, make sure that you put this inside the bracket, the x minus 4. The answer that you get, remember we need to equate this to what? To 10. This is my my second difference. You see, when it's like this, it will be easy for us to find the value of x. So when we have the value of x, we can just find, you'll see how we can do this now. So if we continue working on this, this will be 34 minus x plus 4, it's equal to 10. The like terms, minus x, it's minus 2x, it's equals to, then I'll have 10. Okay, 4 plus 4 is 38. Then I know that the 38 will go to the other side to be negative. So we're going to say 38, 10 minus 38 is minus 28. Divide both sides by 2. So I'm going to divide this by negative 2 by negative 2. What is x equals to? Just positive 14. So if I have x as positive 14, this is what I'm going to do. I need to find, I'm sorry if I'm moving fast. I need to say this is 4. Then the next term is 14. Then I have 34. So the difference between this, it will be 14 minus 4. 14 minus 4, what is that equals to 10? Then I need to say 34 minus 14. What is that equals to? 20. The difference is 10. To find the next terms, I know that this is 10. So I need to add 10 to 20. This will give me 30. I need to add 30 to 34 to find the next term. And this will give me 64. Okay, I can do that again. This is 10. I need to add 10 to 30. This will give me 40. I need to add 40 to 64. This will give me 104. That's how we find the next terms. So you can do that to find the next terms. Then you're going to say, therefore, the sequence is 4, 14, 34, 64, 104, and so on. So the most important thing about this is for you to make sure that you analyze the question, you understand, you make sure that you understand whatever that is going on the question. Joanna, I'm not sure if it's Joanna, but Joanna is asking, how do you know this? How do I know what, Joanna? How do I know what? I'm waiting for you. How do I know what, Joanna? These questions, how to answer the questions. Again, I'm training you so that Luana, you can be the best. I'm training you so that Luana, you can be the best. Okay, do you guys have any question based on this one? Okay, no questions. Okay, thank you, Evelyn. So these guys are the type of questions that you should expect when you are working on an exam, and these are the type of questions that most of the time we don't pay attention on them. Most of the time we don't pay attention on them. So now the other one that I want to move on, is how is the domain and range. Ne? Remember, I'm just giving you the tips on paper one. Ne? So the next thing, remember this is just exam tips, is the domain and range. So when we work on the domain and range, I know that you guys understand this. When I say domain and range, someone will say, why teach domain and range? This one are the same, right? You'll see why it's important for me to explain this. This will make sense now. That if we let's say I give you an example and say I have my equation like y is equals to 1 over x. So I have y to be 1 over x plus 1. I need you to determine the domain. We can see that this has to do with hyperbola, and if I look at the graph of hyperbola, it looks like this. Now the shape of the graph looks like this. So it takes all y values and all x values. So the domain will be x must be an element of real numbers. But there are some of the things that we don't pay attention, especially when you are doing grade 12. You need to make sure that you get this thing right, because it's not like when the person will be marking your script, it's your teacher, and they'll say, this is Tabo. We know that Tabo is well disciplined. I'm just going to give you a mark, boy, because you know what? I like you and you are. It doesn't work like that in matrix. So these are some of the things we need to discuss. Look at this. I know that the domain of this graph, it's always the same, like x must be an element of real numbers. But we forget to talk about the restrictions. Always tell them, look at this. What will happen if the value of x is 0? What will happen if your denominator is 0? Can you see that if your graph touches 0, if the graph touches this 0, then we are in trouble. If your graph touches this 0, our graph will be undefined. The domain, x must be an element of real numbers, but x must not be equal to 0. Understand? X must not be equal to 0. Now look at this. What about the range? X must be an element of not x but y. So on the range we'll say y must be an element of real numbers, but y must not be equal to what? 1. So I'm going to conclude and say that when you determine the domain, always reject your horizontal asymptote and your vertical asymptote. You need to reject them. It's very important. So now, most of the time, this is grade 10. This is grade 10. So if we move to the grade 12 type questions, this is how they're going to ask it. Let's say it comes in this way. Okay, let's do this. Let's say it comes in this way, and we say that y is equals to 8 over x minus 8 plus 4. Please, we know that the domain of this graph, its x must be an element of real numbers, but we need to reject the asymptote. So we take whatever that we have on the denominator, we equate it to 0. It must not be equal to 0. Then when we solve, x must not be equals to what? X must not be equals to 8. So we need to reject and say x must not be equals to 8. Because if you only say x must be element of real numbers, then everything is just wrong. You're going to lose that 1 mark, easy mark. Ne? And the range, same applies. Y must be an element of real numbers, but we need to reject y must not be equals to that form. It must not touch that form. Okay, I hope this makes sense. Ne? I hope this makes sense. I'm still looking for some of the mistakes that you guys do, but we'll keep on working on this type of questions. Né? I think we've done enough for for today now. I think we've done enough for today, but one thing I still not sure about is you guys, if you can determine if the graph is increasing. They'll ask you for which values of x is this graph increasing, or is this graph for which values of x is this graph decreasing, something like that. Né? Those are the types of things that we're gonna discuss on our next lesson. But let me leave you guys with this. Né? Let me just leave you with this. So let me explain increasing and decreasing. Né? So if I have a graph like this, if the value of a is greater than 0, your graph will be concave up. I need to explain how this works. Né? Most of the time you'll see in an exam they say, for which values of x is f at x increasing? You see, those are the type of questions you guys get wrong. And please, those ones, I always like to say, you guys, I'm very sorry if someone is offended. Né? I'm very sorry. Yeah, but listen, when they'll say for which values, I'm busy thinking about something. If it was a white person saying you guys, black people will be offended. Yeah, né? For which values of x is f at x increasing or decreasing? Né? This is what I'm going to teach you how to answer this question. Look at this. We always move from left, we go in that direction to the right, always. That's the first thing you need to understand. You're going to see. This is you, Evelyn. Né? I'm just going to draw Evelyn on the board now. Okay, this is you, Evelyn. You always move from left to right. You don't change direction. No matter what, you always move from left to right. Né? So this is going to be you, Evelyn. You're going to move. This is you. You are standing here. There you are. So you're going to move from left to right. Can you see that the moment you start going this side, you are going down. You are decreasing. You are decreasing until you reach the turning point. Then when you are on the turning point, the moment you start going up, you are increasing. You are increasing. So what I'm trying to say is that this will be the line of symmetry. So let's say that x is equals to minus 2. I'm just giving you an example. The turning point was -2 and 1. So the x coordinate is just what? Minus 2. So when they ask that for which values of x for increasing, where is this thing increasing? I'm going to change the marker here so that everyone can see this. Look at this now. From this point going up, you are going up a slope, so you'll be increasing. So this tells us that f at x is increasing if x is greater than what? Is greater than -2. Please don't say greater or equals to. Just say it's increasing if x is greater, because we start from -2, we go in that direction. So x must be greater than -2. If they ask you where is this graph decreasing, it's going to decrease. Look at this. Where are you decreasing? You are decreasing this side. Né? Maybe we should also. You are decreasing this side. You see? This side like this, you are decreasing. So this tells us that you are decreasing from this point, moving that direction. So x must be less than -2. So that's how you explain the increasing and decreasing function. So now let's change and say, let's say the value of a is less than 0. If a is less than 0, how will your graph look like? You're going to be concave down. Look at this now. We're just gonna put Evelyn there. This is you. You'll move left to right. You always move left to right. So look at this. This point, you are going up. You are going up until you reach that axis of symmetry. Then you'll start moving down. You start moving down. So this tells you that from this point here, it's where we change the concavity or whatever. This will be increasing and this will be decreasing. So where are you increasing? If this is x, let's say x is equals to 4. So where are you increasing? So in order for you to increase, I'm just going to write this in blue. So x must be, you increase from this point going that side. So x must be less than 4. So can you see the difference? Can you see the difference? And then you are decreasing, x will be greater than 2 because you are decreasing from this point going that side. So it also depends on the value of a. And ladies and gents, this is where we're going to stop for today. Can you guys please tell me if you have any questions? If you guys understand what we did here, are you all happy? Can you please comment your name, guys? I need to check the number of the learners that are left. I just want to see your names. How? John? Oh, John said, how do you know this? I need to see the names of learners left in the comment. I mean in the live. Can you please raise your hands, guys, so I can see your names? Kuto, I see you. Isona, I see you. Katlero. Why the number keeps going up? Okay, it's fine. Bongeka, I need last one. This last one. Who's that last one? There were 5 learners. Who's that last one? Okay, it's fine. Thank you guys. And this is where we're going to stop for today, né? Thank you very much for attending, guys. Thank you very much. I'll see you guys on our next lesson. Let's do this tomorrow, same time. We're going to cover 2 hours tomorrow, né? Thank you and have a great night. Bye. Sharp.